And a lot of this stuff is already kind of familiar to you probably. So the first thing we're going to talk about is kind of this whole thing called plate tectonics, right? Plate tectonics, we talked about other planets, and Earth is unique in that basically it has part of its crust that can slide around. That's plate tectonics. And if this kind of looks like a Frankenstein picture, okay, that's because each color here is a different plate, okay? So these are kind of where the breaks are. So this is kind of a little bit of deja vu. Clear back when we talked about astronomy, we said that our solar system, our sun turned on about 4.6 billion years ago. So that's kind of when we say the Earth was kind of, had all the stuff it was going to have. And it was pretty darn ooey gooey. We talked to, no, I get my classes mixed up. But early on, there was kind of miscellaneous stuff running around the solar system, kind of bombarding the Earth. Then it settled down. So when the sun turned on, all of the planets cooled, including the Earth. And it formed a crust. Now we're going to talk about kind of different types of rocks. Here's your first type of rock, an igneous rock. So basically way back when the Earth went from molten to having some sort of a film on the top because it was cooled, that's your igneous rocks. So igneous rocks are very old. And we didn't spend, your Shipman does a good job, I think, talking about just basically what's called nuclear or radioactive decay. Some of those elements, basically, they fall apart, and it's a type of fission, okay, just naturally decay into simpler elements, okay, the metals do. And in doing so, they release some energy. So actually, that sort of decay process has been going on ever since those metals have been part of the Earth. So that's actually an extra heating mechanism. So I think we talked about planetary differentiation. I don't know if that rings a bell. The idea that basically heavier elements sank for all of the planets, including Earth, and the lighter elements rose. Okay, so when we look here in a little bit at the Earth's core, oh my gosh, it is like crazy dense, okay? And we have lighter stuff that is on the Earth's surface. So with regard to elements, iron is relatively abundant in kind of the stuff that made up the planets, and heavy. So iron actually has sunk and created the cores of the planets, including Earth's core. So what is the core like now? Well, it's pretty warm, 6,000 Kelvin, but not nearly as warm as maybe some things. Oh my gosh, degrees Celsius, not Kelvin, 6,000 degrees Celsius. But that's kind of about the surface temperature of the sun. I just realized that. That's kind of interesting. The Earth has a magnetic field. I think we talked about that when we talked about planets. I'm not sure. I think we did. The magnetic field is kind of, we had a picture of the Earth, and we had kind of these kind of ghosty looking things. Okay, Earth has a protective electromagnetic field. And we're kind of unique in that with regard to the rocky planets. And because it has a magnetic field, we know that it's gooey gooey in the center. We can tell kind of its internal structure by how gravity is on the Earth's surface, how heat flows. Okay, and this is, I don't know if I mentioned this before or not, but if you're wanting to know what's happening on the interior of a planet, actually you can look at seismic vibrations. And the movie Tremors, I always think of that movie where the lady was out, this lady scientist was out putting posts in the ground, and then she would go over there and she would like look for vibrations, a very sensitive post. And then of course the creatures were, the Tremors were, yes. Okay, so I have a video and I think we'll have just about enough time to watch the video. I think it's like 14 minutes or so, that kind of talks about the structure of the Earth. Let's see if it works for us.